In this video, we're going to talk about multiplying polynomials. And so if we read the instructions, it says find the product and then write your answer in standard form. So in this first example here, we have 6 times the binomial n plus 7. And so just as a word of caution, when I see students do this a lot of times, I see them say, oh, well, that's just equal to 6 times n and then plus 7. That would be a pretty big mistake that I see a lot. Just be very careful with that. So let's erase that and let's talk about how to do this correctly. So when we're looking at this, we're going to have to distribute the 6 to both pieces. It's 6 times n and 6 times 7. So 6 times n is just 6n, is how we would read that. And then 6 times 7 is a positive, so I'll have a plus and then 42. One thing to just double check is to make sure that's in standard form, and it is. So I'll just circle my answer. All right, let's look at this example 2 here. In example 2, we have x and then minus 3 times 6x plus 8. When I'm doing this, just be very cautious. The x isn't going to be multiplied by anything. The negative 6 is times this piece right here, so we're going to have to distribute the negative 3 to both pieces. But the x is just going to kind of come down with us, and we'll combine that later. So I'll have equals x, and then negative 3 times 6x would be a negative 18x, and then negative 3 times 8 is going to give me a negative 24. So all we would do at this point is just look for like terms. It looks like we have an x and a negative 18x. Remember with this lone x here, there's an implied 1 in front. So it's going to be 1x minus 18x, which would give us a negative 17x and then minus our 24. Again, we would just double check to make sure that's in standard form, and it is. So we'll circle our answer. All right, let's look at one that's just a little bit more complicated. Same idea here. Just when we're looking at this, we've got to make sure that we multiply both of these pieces to both of those pieces. There's definitely a few ways to do this problem, but I'll show you one of the most common ways that I know of, and that is to simply take this 4a and multiply it to both pieces. So we'll do 4a times a, which gives me a 4a squared. Remember, a times a is a squared. And then we'll do 4a times 8. That'll give me a positive 32 and then a. And then we'll do the same thing to the negative 4. We'll do negative 4 times a and negative 4 times 8. So negative 4 times a is a negative 4a. And then negative 4 times 8 is a negative 32. So I'm just going to glance through there and see if I have anything that I can combine by adding or subtracting. And if you notice, there's a a positive 32a and a negative 4a. And we can add those together, and that will give me, so I'll have the 4a squared, and then 32a minus 4a gives me a positive 28a, and then I'll have minus 32. All right, one common error I do see on occasion is that students will try to add these. Remember, they're not like terms. This is an a squared and this is an a, and they can't be combined. One other thing just to double check is that we're in standard form, and if you look at it, we have an a squared, then an a, then a constant, so we're definitely in standard form. Make sure you get in the habit, especially with these, to write them in standard form. So at this point, we can really just circle our answer. Let's look at one more example here, just like the last one. We're going to do the same exact strategy. I'll do 7x times 5x. 7 times 5, that's going to give me a 35, and then x times x is x squared. And then I'll do 7x times negative 8. Now 7 times negative 8 is a negative 56, so I'll have a negative 56x. Then I'll do the same thing with negative 6. So negative 6 times 5x, that's going to give me a negative 30x. And then negative 6 times negative 8. Remember that a negative times a negative is a positive, So that'll be a positive 48. And then the last thing I'll just look for again is our like terms. When you're multiplying two binomials together like this, that both just have an x there and an x there, these middle terms here, this negative 56x and this negative 30x, those will always be like terms, and we can just add those together. So this should equal a 35x squared. Now negative 54x minus 30x, it's going to give me a negative 86x, and then plus the 48. Again, we'll just double check to make sure it's in standard form, and since we've got an x squared, an x, and a constant, we are definitely in standard form, and so we can simply circle our answer. All right, let's look at this last example here. This one is one of those problems where I see a lot of common errors. A lot of people look at this and they try to distribute this squared to both pieces and say, oh, this is just equal to 25y squared plus 1 squared, which is 1. If you do that, you're kind of missing the mark. So let's erase that and let's look at how to do this correctly. One of the things I want you to think about before we jump into this is if I gave you something like 2 squared, that would equal 2 times 2. Or similarly, if I gave you, say, 5 cubed, that equals 5 times 5 times 5. Now, that same idea applies with our binomials. Since I have 5y plus 1 quantity squared, that means I have 2 of these 5y plus 1s. So I'm going to write this as 5y plus 1 and then times 5y plus 1. Sorry, my 5s look a little bad. I'm not very good at drawing 5s. I'm sorry about that. So once we recognize that this equals this, similar to why 2 squared equals 2 times 2, or 5 cubed equals 5 times 5 times 5, then we can just simply multiply this out like we've done in the past. So I can do the 5y times 5y. Now 5 times 5 is 25, and then y times y is y squared. And then I'll do the 5 times the 1, sorry, the 5y times the 1, which will be a plus 5y. And then I'll do the same thing with the 1. 1 times 5y and 1 times 1. 1 times 5y will just be a positive 5y, and 1 times 1 will be a positive 1. And again, since this is two binomials that have just a y there and a y there, then these middle terms will always be like terms and we'll always be able to combine them. So let's make sure we combine those two guys. And this gives us 25y squared, and then 5y plus 5y is a 10y, 12 plus 10y, and then plus 1. And that's really about it for multiplying polynomials that we're going to look at. We could look at some more difficult cases, but it all follows the same idea.